In this video, you will learn how to find the optimum speed for Koko to eat piles of bananas so that she can both eat at a relaxed pace and finish all the bananas while the guards are away. And our solution avoids exponential time complexity. Hello, and welcome to the Python implementation of LeetCode problem 875, Koko eating bananas. The problem states, Koko loves to eat bananas. There are n piles of bananas, and the ith pile has the ith element of pile's value of bananas. The guards have gone and will come back in h hours. Koko can decide her bananas per hour eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more during this hour. Koko likes to eat slowly, but she wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within h hours. For example, example 1. Input piles is 3, 6, 7, 11. Input h is 8. Output is 4. Example 2. Input piles is 30, 11, 23, 4, 20. Input h is 5. Output is 30. Example 3. Input piles is 30, 11, 23, 4, 20. Input h is 6. Output is 23. The constraints are the number of piles is between 1 and 10,000. The number of piles is less than or equal to the number of hours that the guards will be away, which is less than 1 billion hours. Each pile can hold between 1 and 1 billion bananas. What this is really asking is, we have several piles of bananas. Koko wants to eat the bananas as slowly as possible, but still finish all the bananas before the guards return. Koko will eat a certain number of bananas per hour, but she will relax for the rest of the hour after finishing the last banana in each pile. So the time it takes for her to eat all the bananas in a pile is the ceiling of the number of bananas in that pile divided by the number of bananas she eats per hour. Eating each pile in this way, eating at her pace and resting in between, takes some amount of time. This is an optimization problem where we want to find a maximum value that produces an output within some target range. This is a binary search problem. We can guess this because it works on a list or a range. It finds a target value, minimum or maximum. It does not get split into subproblems, and it does not work well with a greedy algorithm. If you're serious about acing coding interviews, I've got something that will help. Sign up for the LeetKey newsletter and get weekly LeetCode problems, detailed solutions, and proven strategies delivered straight into your inbox. Now back to the video. You might be inclined to solve this by calculating how long it takes to eat all the bananas at every eating speed from 1 to the largest pile size, then returning the eating speed with the maximum allowable time. But this approach loops over both arrays in a nested loop, resulting in an exponential time complexity. A more optimal approach is to use a binary search over the eating rates and to calculate the time to eat all the bananas at each step of the search. This way, we only need to calculate enough values to narrow the search window and find the solution. This solution searches the eating rates more efficiently as it scales, but still must loop over every number in the piles array, resulting in an O(n) log n solution, a big improvement over the last implementation. Let's see how to implement this solution. This solution works by calculating the time required to eat all bananas at different speeds. We use a binary search between 1 and the largest pile size to search for the slowest working speed. We start by defining the possible eating speeds from 1 per hour to the largest pile size. We loop until the search isolates a single result. At each iteration, we find the value halfway between min and max and check how many hours it would take to eat all bananas at this rate. We do this by manually counting the hours it takes to eat all bananas at this speed. Koko will eat until she finishes a pile, finishing the last hour without eating from the next. So we can estimate that a pile will take the maximum value of piles divided by that rate in hours for each pile to get eaten. Knowing this, we can check if the guards will return before she finishes eating. If so, she must eat faster. If not, she can eat slower. This continues until we find the slowest speed she can eat before the guards return, which we return as our solution. The space complexity for this implementation is static, since we don't create any dynamically scaling data. The time complexity for this implementation is n log n, since we cut the search space in half at each search loop, but must iterate over each pile to calculate the total eating time. That was how to solve LeetCode problem 875, Koko eating bananas. Thank you, Flavio, for subscribing. Next week, we will be looking at problem 1137, nth Fibonacci number. So subscribe and click the bell to get notified when that drops. And let us know in the comments which problems you'd like to see next. Please share this video with any programmers or aspiring coders you know that you think could benefit from its insights. It's word-of-mouth referrals like yours that really help this channel grow. You can get this video a few days earlier, plus other exclusive content on our Patreon.